Good morning. Today we are talking about exponential functions. We are going to learn to write equations and talk about key features of exponential function graphs. This is TEKS Algebra 1, 9B, 9C, and 9D. Our parent function that we use for exponentials is y equals ab to the x. Now, a is going to be the number that does not have an exponent. If you have an a, it'll be in front of parentheses. A is your initial value. It's your starting point. The huge thing I want you to remember from this, though, is that a is actually your y-intercept. Our b is going to be a factor of growth or decay. B cannot be 1. So down here we have these two graphs. Now, what are these two graphs? The first one is f of x equals 2 to the x. Well, when your b value is greater than 1, in this case it's a 2, it is called an exponential growth. If the b value is less than 1, this is called an exponential decay. Now, what does that mean? What does growth and decay mean? Growth means that the graph from left to right is increasing. Decay means the graph from left to right is decreasing. Now, one thing I want to point out between both of these is that look at the y-intercept. The y-intercept is 1. The y-intercept is 1. Because you don't see an a value is 1. If you just have a b to the x, then it is always going to cross through at y equals 1. Now, why is that? Because anything to the 0 power. So if x was 0, I plug in a 0 here. Anything to the 0 power, this would be 1. Another thing about this graph is we do have asymptotes. An asymptote is an invisible line that your graph is never going to cross. For Algebra 1, our asymptote is typically going to be y equals 0. The graph is going to get really, really close to it, but it's never going to cross it. Again, y equals 0 is my asymptote. Okay, so we're going to talk about how to write equations. So we have a times b raised to the x. And we know that a is our starting value, and b is either our rate of growth or decay. Now, sometimes it tells us what number to put in there. If it says doubles or triples, we know what number that is. But sometimes it gives us a percent. So we have to figure out if it's a growth, we're going to do 1 plus the percent, but the percent needs to be converted to a decimal. If it's a decay, it's 1 minus that amount. If I'm telling you something is decaying by 10%, that 10% means it's 1 minus 0.10. That means every hour you check it, it's really 90% of the full value. So let's look at this first question we have here. We're going to start with this one, okay? Suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles every week. Write a function that models this data. So keywords that we need here. We have 30 beetles. The beetle population doubles. Okay, well, what does doubles mean? What value is doubles? Well, doubles is a 2. So my starting value is 30. My b value is the rate of growth or decay, and this time it is increasing by a rate of 2. So my function is going to be f of x equals 30 parentheses 2 raised to the x power. Notice every single function we write is going to have an x in the exponent. Let's try the second question. If the amount of Tylenol in a person's body decreases by 20% in an hour, you take 500 milligrams of Tylenol. Write a function that models this data. How much medicine is left in your system? Well, our starting value, important things we have here. You started with 500 milligrams. It's decreasing by a rate of 20%. So our A value is going to be 500 milligrams. My B value is going to be 1 minus, because it's a decay, it says decreases. 1 minus, and what is 20% as a decimal? 0.2. 1 minus 0.2 is 0.8. So for every hour you take it, you actually have 80% in your system after every hour. So there's my function. Okay? My next question. If the starting population of 5 rabbits triples every year, write a function that models this data. So you have 5 rabbits, and it's tripling each year. So my A value is 5. So I'm starting with 5. My B value, they said it's tripling, which means it's going to be greater than 1 because it's increasing, and tripling means it's going to be 3 times the amount. So my function for this is f of x equals, I start with 5, but it's tripling every year. X stands for the number of years. So again, if I have 0 years, 3 to the 0 is 1. I'm starting with 5 rabbits. The last question on this page. You have approximately 10,000 fire ants outside. You put ant powder down and they start dying. About 10% die per minute. Write a function that models this data. We start with 10,000. They are dying at a rate of 10%. So is it a growth or is it a decay? Well, since they're dying, this is a decay. So my A value is going to be 10,000. My B value is going to be a 1 minus 0.10, which is 0.90. So my function is f of x equals 10,000 times 0.90 raised to the x, and x stands for the number of minutes. And now we're going to evaluate some graphs that are exponential growth or decay. So we look at this graph, is this a growth or decay, and explain. Well, the graph is decreasing from left to right. So from left to right, it's decreasing. So we're going to write it's a decay. And our reason is just that, because it is decreasing from left to right. The next question is, what is the starting value of the car? Don't forget that this would have been our A value, and our A value stands for my y-intercept. So that right there is my y-intercept. It's also the value of the car. So we're going to approximate between 30 and 35. It looks closer to 30, so we're going to say 32,000. The next question says, in 4 years, what is the value of the car? So now we look at, does my x value or my y value talk about years? Well, my x value is years. So I'm looking for when my years are 4. So I'm going to follow this 4 all the way up. How much is my car worth? So 4 all the way up till it touches the line. And then we go over. This is approximately $17,000. Now the next question is, when is the car worth about $8,000? So the side, the y value, says value of car in thousands. So we're not looking for the number 8,000, we're looking for the number 8. So 8 is approximately right here. And we're going to follow $8,000 all the way over until we touch the graph. Okay? And where do we touch the graph? How many years? It looks like in 8 years. In 8 years, your car is only worth $8,000. Okay? Do it again. So bacteria growth. Is this a growth or decay model? Well, it's a growth. Why is it a growth? Because it's increasing from left to right. What is the starting value of bacteria? Where does it start? Well, it starts at my y-intercept. Now, this one's going to be very, very tricky because it looks like 0. But I'm going to tell you this right now. Your y-intercept can never, ever, ever be 0. Because no matter what you raise the exponent to, your value cannot be 0. So I know that these are big jumps. This is 1,000. We're just going to go ahead and say that the starting bacteria, we're going to say it's 1 unit. Again, it can never be 0. If it looks pretty close to 0, we can go ahead and start saying 1 if they did not tell us what the starting value was. In 12 days, how much bacteria will be present? So this is days apparently. So in 12 days, how much bacteria was present? So here's an actual point, and we're going to follow it all the way over. The answer is 4,000 units. Just shows how fast bacteria can grow. The next question is, when is there about 16,500 units of bacteria? So here are my units of bacteria. Here's 16,000. Here's 18,000. So we're looking at about halfway right here. So we're going to follow this halfway right here all the way over. I'm touching this dot right here. So I follow that going down, and the answer is 14. Now, I apologize, this graph doesn't have units on the bottom, but because the last question said days, we are going to put days. Let's evaluate one more graph. Let's look for key features of one more. Family population, based on the number of generations, how many members are in your family per generation? So first question, is this a growth or decay? Well, it is increasing from left to right, so it is a growth. When it says explain, we must explain. Again, increasing from left to right. The next question is, what is the starting value of the population? Again, it looks pretty close to 0, but we can never have 0. So we can say 1. Now do realize though that this is basically your family tree. So if you go back as far as you can, you typically have a great-great-grandpa and a great-great-grandma. So I'd actually be comfortable putting 1 or 2 here. When is there about 500 people in the family population? So here is the number of people. Here's 500. We're going to follow the 500 over. At what generation? Okay, that follows 6 generation. So we're going to put after 6 generations. In the 9th generation, approximately how many people will be part of the family? So in the 9th generation, we're going to follow the 9 going straight up. Okay, there's the blue dot that corresponds to 9, and then follow it over. It shows that there are approximately 2,500 people. Thank you for watching this video. If it helped you and you would like to give it a thumbs up, and also subscribe to my channel where I will be posting more educational videos. Have a great day.